for the serial and parallel communications. Definitely we have. So just going for some detailed descriptions of the programming. So I'm not wasting the time and just coming towards the programming side, as we have some informations about the order pins that we already discussed. So I'm just giving some brief overview of the port 1 and port 2. So both port 1 and port 2 are usually can be used for the simple input output port, and these input output port can be used for the bidirectional purpose. And definitely we have the three, that is the port 3 that can be used for serial communication, external interrupts, timers, read write operations of the signals to the external memories. So it is the general building blocks for the 8086 and it is the 8085 microcontrollers. Definitely we have dedicated ROM, that is a 4 GB dedicated ROM, 128 byte RAM, and generally we use the timer 0, timer 1 for the timing communications. Definitely we have some serial mode communication. So directly just coming for the assembly language program, just keeping all the parts. So already it is being discussed in the class. So now it's the important part. It's a 120 byte RAM, and definitely we have some registers. So we can see this register bank 0, register bank 1, register bank 2 and 3, and it is already 128 bytes, and it is divided into the three different groups. And the third group is the general purpose area, and definitely we have some spec pairs, and we have some memory addresses for the 8051 RAM. So we have self discussion for the bank 0, bank 1, bank 2 and bank 3, and we can have the data can be stored in a particular space, and the addresses are completely specified as we have the register bank 0. So if you see the register bank 0, 1, 2, 3, so we have the registers R0 to the R7 which are in the gradient, and so definitely we all have the address for the registers bank 0 to the register bank 3 from 00 to the 1F that will be displayed at the interfacing simulator that I already shared to you. So the basic instructions for the programming. So the programming, the part we have already. So if you see, suppose if we go through the immediate addressing modes, so this is data pointer, the DPTR can be used to access the two 8-bit registers, and the higher byte, that is a DPH, and low byte DPH. So here we have some codes, and definitely we can implement using the simulator, and we can use some register addressing modes for assigning the data to the memory locations. So suppose we have some gradient for the instructions. Here we can copy the contents of the registers into the accumulator, and after the processing that we can have data that can be saved for the specified locations. And we have some different purpose for the data manipulation in terms of the programming. So here this is the SFR register for their addresses. Suppose if you want to communicate the data which is already having the value, then if you just want to copy the data into the accumulator, so it is not required to mention the name for the, here it is the A, B, C and D at the particular behalf, that is the special function registers will have their addresses for the register A, that is the accumulator part, that is the special function register B. So we would have the proper specific addresses which is completely 0E, 0H and definitely 0F, 0H for the accumulator and the register B. So we can assign directly, as we have the special function addresses for the accumulator, B registers, programmers, status word, stack pointer, data pointers, and some of the low byte and high byte from port 0 to the port 3, and that is the interrupt priority control to the timer control mode control registers. So we have these special function registers addresses also. So some of the examples that we can communicate over here. So I am just sharing one of the examples that we have to write the code to send the 55 hexadecimal value to the port P1 and P2. by using their names with their addresses. So one of the best example to execute over here by using the simulator. So first of all, you just open the executable jar file, and you need to start with the code with the starting of the code, that is the org, that is the org 008. It means you are keeping all the register banks with zero values. Right now you are storing the data, that is the 55H hexadecimal value, that is to be stored in the accumulator part, and here this accumulator data is to be assigned to the port P1 and port P2 sequentially, and definitely we have to end the program by deploying the instruction which is END. So you need to start and you need to check whether it is showing your data memory or not. And suppose if you want to deploy that particular code by using the special function register specific registers addresses, then definitely you can use the command, that is mob0a0h, and definitely it is also giving the assignment for the value of 55H to the port P1 and P2, and you can show the result here with the data memory side and address memory side. So you may have a look and you can check whether it is working or not. So it is just being started with the code simulations, and it is very basic code program. That is the first. Then if you are going to assign the value 55H to the port P1 and 55H value to the port P2, and it will be completely reflected over there. So with the continuation of this code execution, so I'm going further again with some commands. Now this time show the code to the push R5 and A onto the stack, and then pop them into the R2 and B, where V is equals to A and R2 is equals to R5. So suppose if you have, then the solution it will be there. So first of all, the value 05 that is required to push, that is the push R5 onto the stack. Again, you are just going to push 0E08. It is specific address for the register A. So now again, this is push register A onto the stack. And after that, you need to pop. That is, you want to retry the data. So pop top of the stack into the B. Again, you want to retry the data from the stack into the R2. And now this R2 is equals to R6. Whenever you are just opening the simulators, first of all, you reset all the things. After this reset, it is the command, that is the RST. When you are clicking over there, you need to write the code into the assembly language program form. After that, you need to check whether it is having these steps by ASM or directly you can run. If you are checking by step, then definitely you can see what is happening in terms of the execution of the data one by one with applying the commands. Again, I am going to represent the another assembly language program.
Dr. Amarjit, nothing is visible. Is Pratik Jain sir with us?
Yes, sir. Actually, he is presenting program. So students are requested to on your program screen, all of you.
So this time I think you may have a look of this screen, and definitely we can go through there. So this time, if you see, if you're writing the code over here, that is the code blocks. So whatever the code I share to you, so right now I'm just writing the code over here. So maybe it will be reflecting to you. So just wait. Oh, I think the complete screen is visible to you right now. So I am just going to write the code over here. So this time I'm writing a code for the assembly language program to find the average number of n byte of the data. So first of all, we start with the organization 00h. Here we are going to reset all the values. Again, that is the move, and that is R naught. That is, so definitely I'm going to copying the data into the R naught. It is 30h. Again, that is a move R1, that is a 0AH. So here it is 0A H value, and it is a move new command, move V here to the R1. So here we have the register move the R1, and again that is a move A, comma, so again the value. So first of all, we have already assigned the value, that is 30h to the R0, and this is a 10 value to the R1, and R1 value is assigned to the B, that is the special function register. Again we are keeping the accumulator which is at the 0 value. So again I am assigning the label which is repeat. So here this is repeat, and here it is add a. So here this is the command is add a at rate r naught. It means the data at the location of r naught is required to be added over here with the accumulator value. Again, the new value which is increment of r naught, and the new value this is t, j and z, data jump of not 0, r1, and it is a repeat. So finally, we have to divide the value of a and b, and again we have to end the program. So first of all, this is the complete program. It is starting from the organization of the 0 it is starting of the code, and we are ending the code with the end execution command. And after that, we have to check the code is properly working or not. It is having error. Okay, it is not having any error, so it is no error. It is displayed over here. So again, I will click on this step again to check whether the value is displaying or not. So here this 30 value is assigned to the R0, as you can see to the left side, downside to the left one, the value 30H is assigned to the R0. Again, I will click on the value. So the R1 value is assigned to the B. So this time your R1 value is assigned to the B, and your accumulator is keeping on 0 value. Again, your R0 value, the location of the R0 value is assigned to the value to the A after the addition. So the new value, that is the increment of the R0. Again, your R0 is increasing, as you can see. This R0 is having 31. Okay, and after that you would have the division value, that is divide A and B, and you have answer. So finally, if you are just clicking on run, then what do you see? That is the accumulator value you have, that is 37, and your R0 value is having particular 30, and this time your program is running one after the another, and your program counter is increasing. As I have taken the updated frequency of 50,000 megahertz, definitely I have to keep out there, so you can check whether the left side, this is 767771 microsecond, it is giving the time, the duration, and now the program is running as it is starting from the initial value, and it is ending over here, and you may have a look. So this is right now left side, it is visible, that is the data memory, and right now you can see the data memory with the first cycle, first, that is 7830, and now you have data that is visible to the side, and definitely you will have the final value which is already stored to the R0. Okay, and the accumulator value is having, we have this time, and the stack pointer, that is completely we have already. So this is completely interfacing by, from here you can see the code is being run this time. So maybe the new code, as you have to write the code, and maybe you would have the new program that you can run on simulator over here. So just check it once and tell me if it is being possible from your side. So this code is being run from your end. So I'm going to share the another program. So the next code is given over here. Maybe you can write the code, and the screen is shared amongst to you. So this is the writer program to
All of
load
you,
the
please see
accumulator with
the
the
code.
value of 55H and complement the accumulator 500 times. So here's the solution. Since 500 is larger than 255, so the maximum capacity of any register, we use two registers to hold a count. So the following code shows how to use R2 and R3 for the count. So we have to start with the count sequence. Definitely we have the value which is 55, and that is stored to the accumulator. And again the count is starting, that is register 5. So this is R3, 5 to the R3 again. So okay, so we have to start with the register count, and definitely it is almost 500 times. So first counter that we have taken 100 times, and second it is 100 by 5. Okay, so this 100 counts will be iterated by 5, and we have to complement the A, and it will be having up to when we have the command that is greater than not 0. So again we have to go this one with the start that is 100 times, and again we have to apply the complementary. So after this gradient of these instructions, we can go through the complement the value of the accumulator by 500 times, and you can check, you can have the answer with the data memory. So once you need to check, in between I will be sharing the code on the simulator.
Now Pratik sir is showing the simulator of that problem. Yes. So please write the code. This is a new
So
program.
here I am just going to write the code of writing the code of the load the accumulator with the value of 55H, and we have to complement up to the 500 times. So that we have to start with the loading the value to the accumulator. So the second line is this being written, and this is one of the outer counter, that is multiplied by 5, that is 100 multiplied by 5. So definitely we have 500 times, and we have to start with the move R2, comma, that is the hash 100. That is a complementary, that is a CPL, this is A. So now this code is ended. So first of all, we have to check, is there any error in this code? So first we have to check and we have to reset the button.
Reset button.
And again we have to check the code. So there is no error. It is mentioning over there, it is no error. So again we have to apply the step by step. So the step, that is the first step is executed. So now you can see the left side, accumulator is loaded with the 55 value. And again, the new step, it means R3 is assigned by 5, as you can see. And the next step, that is the complementary of the A, that is now used to be required. So again, this move R2. R2 is having the value that is of 64. It is in the hexadecimal value. And again, so after this running with the value, you have to apply for the run. So it is being run by 500 times, as now you can see. So finally, so what is actually, now you can see, this is the complement of the accumulator 500 times. And the result would be displayed in the data memory, as you can see. So it is just being, if you're just changing the frequency, then definitely it will be going to faster. And we have visibility of the data in the data memory. So now you can check the data is in the data memory. It is visible over here. Okay, so just confirm me here, is the program is running or not? So again, now we are going to start the new code, which is the example for the assembly language program to subtract two BCD number. So in between the code that we have to avoid some commands, then definitely we have to go through there. That is a move or not. So for this one, we are going to keep the value 30H to the register R0 and increment of the value of the R0. Okay. Again, we have to load the content of the R0 at the accumulator. So for this one, we have to apply the commands. That is move A at the rate R0, and now this time the value of R0 is moved to the accumulator, and this value of the accumulator is moved to the R2. So again, we have to apply the new command, which is move R2. It is A. So this time the value of R0 is being moved to the R2, and again we have to assign the new value, which is 99H, to the accumulator. So for this one, we have to apply the command, which is move A, comma, hash 99H. So whenever we are attaching the values, then definitely we have to use by hash. If we are using the at the rate, it means we are going to store or retrieve the data from that particular memory location. And after that, for the subtraction purpose, we have to apply the command, which is subtraction. So for the subtracting of data of the accumulator from the R2, so here we have this is SUBB, it's the accumulator, and it is R2. And again we have to add the data. This is add A by 01H. This is one increment. And again we have to decrease the value of the R0 as we have to go through the decrement of the value. And again this add the accumulator with the location of the data at the R0. And direct decrement the accumulator. So it is B double A. And again that is the move of the data of the accumulator to the register B. So the answer will be stored and will be reflected over here. So first of all, this is the completion of the code, and then we have to check whether it is having or not. So first of all, we have to check the assembly codes. Is there any error or not? So it is showing it is no error. And again, we have to apply the run command. So this step by step we are going through there. So first of all, the value 30H is assigned to the accumulator. Sorry, it is in the R0. So now you can see at the left hand side, the R0 is representing the data of 30H. So the next, again this R0 is increased as we applied the new command, which is increment of the R0. So right now it is 0x31, it is representing the 31H. It is showing the hexadecimal data, which is 31X. Again, the value of the R0 is represented over here, and definitely we have to go with each and every position, and we have to check the code completely, which is representing or not. So right now you can see this accumulator value is having the 99 and it is being the 0, and the data is being stored at the location B. So right now you can see at every iteration you would have the values. That is a subtraction of the 2 BCD number. So you may have a screenshot of this code. In between, I am adding the another code. And then I would be able to explain the code in detail. So just the next code is the program to display a moving bit sequence, and that will be moving in the sequence, and definitely you may have this interfacing the data with the data memory, and the data will be in sequence, that is in moving sequence you will see. So just take a snapshot of the code that I already written over here. So right now we are going to write a sequence for the moving bit sequence to display the moving bit sequence. So here we are just going to start with the port. There is a port EQ. It is 0F800H, and port register, that is equation, that is 0F803. So here we have the conditions and the values signed to the registers, and again that is SCAP EQU. So we have taken the pairing of this EQU 003 EH, and again we need to apply the commands for the data pointer for the port register. So definitely the value at the port register, which already been defined as a variable, it is required to be transferred to the data pointer. So this move DPTR, that is hash, which is the value, which is port REG, and again the value at the accumulator is required to be assigned by ATH. So this is move A hash ATH, and again there is a new, immediately there is a move command for the auxiliary memory. There is a move X at the rate DPTR. So the value at the location of the data pointer, it is required to move the data of the accumulator to the DPTR at the location of DPTR. So definitely we need to apply the command. This is move X at the rate DPTR, comma A. Again the new command is required to be executed. This is MOVA01H. So it means we need to apply the command. That's the move A, because we are going to fill this accumulator by the value by 01H. Again we need to start with the data pointer. So the port A value is required to assign to the data pointer. So here this MOV is DPTR. So it is having some complication of the code, as we need to generate the sequence, that is hash, and it is PORTA. That is the port A. Already we have assigned this port A. As you can see in the first line, the port A is assigned by the value, it is 0F800H. And again we have to start with the labeling, that is the begin. Again that is the move X. That is the move X at the rate DPTR. It means we need to provide the value of the accumulator to the DPTR. Again is this rotate accumulator left. So it is the command, this is RL, comma A. Again we need to apply the command, this is lcall escape. Again we need to escape the code. Here this JC exit. So we need to assign, now this time we have the new label, which is exit. So we need to give, so here this is a call display. So the new call that is being to assign. Okay, so delay is being provided. Again serial in jump. So definitely we need to apply the command as JMP. That is the begin. It means we need to apply the jump command over here with the delivering. Then again exit. That the label is required to be assigned. So what is the label for the exit? It is move A, comma hash. It means it is 0AH, 0H. So right now, after this exiting of the label, so definitely we have your accumulator, which is the value completely reset. This time again we have to execute the new command, which is move X at the rate DPTR. So what is the meaning of this one? It means we need to swipe the DPTR location also, as we have a value. So it is coming under the exit label again. This is the here. So new label is assigned to this here. What is that? That is the SJMP here. Again, we need to apply the delay, which is the delay. So delay is required to assign, as we have already assigned in the loop. That is a delay. So what is in the delay? It is move R naught by 0 FFH. It means we are providing the delay with the highest, that is the peak. Okay, and again the loop 1. Again we have to assign the loop 1. So what is the loop 1? It is move R1 by the value, it is hash 0 FFH, and again the loop 2. So first of all we have to check the loop 1 and loop 2 that already we assigned. That is the loop 1 and loop 2. It is okay or not, because it is case sensitive. So once you need to check whether you are just taking the case sensitive, it means the label should be properly assigned here. So what is the loop 2? Loop 2 means there is no operation, it is NOP. And again for the NOP, this is D, J and Z. R1 is assigned to the loop 2. And again this D, J and Z R0 is assigned to the loop 1. So the loop 1, loop 2 can be carefully taken if you check the value of R1 and R0. Okay, because this is conditional jump here. So now we are closing the command. It is RET, that is returned to the 0 again, and that is the ending of the code. So here from my side, the code is already returned. So whether we need to check it is properly working or not. So first of all we have to check after this applying. So it is showing this syntax that is the RLA. It is RLA. So I think okay, it is by mistake we have taken the comma. Again we have to make it over here. Again we have to apply the reset button. Again we have to check it is assembly. Okay, and now this is representing unknown label R0. So this is not R0, this is R0. So sometimes we have some situations where we have some errors. So whether we have to check the errors are not there. Again I have to click on assembly. So right now there is no error. So if it is not any error, then we have to apply the run. And now whether you have to check the, yes, this time it is asking because we didn't attach the external memory. So we cannot apply this command, this move X. What we have to execute the command and we have to check whether it is in moving sequence or not in the data memory. So we have to apply, that is a no. Then again we have to again run the code, and now you can check that is a data memory. As you can see to the left side, your sequence is moving over here. This is 10 20 10 20 10 20 10 20, and again it is moving. This is 10 20 10 20, and right now you can see your moving sequence is represented over here, and finally it is done. And if you see again, you just keep it pause, reset over here, again you need to apply the run command, and now you can check if it is working. There is 30 10 10 10 10 10, again it is going to the, so it is moving sequence as we have already provided data, and it is having the moving sequence that now you can see. So this time we don't have the external memory, so we cannot show the interfacing, but definitely we have some internal dedicated memory by which we can represent the interfacing and the moving sequence. So definitely we have this moving sequence over here. So just take it into consideration, write down the code. So for your convenience purpose, I am going to maximize this code window, and right now you may write this code over here, and now it is clearly visible to you, the complete code. and you check whether it is working for your case or not. So complete it just once and tell the Omar sir if it is done. So after that, I will give some interfacing with the LEDs, and I will go through some square wave generator and the toggling of the LEDs with the interfacing. So just give me completion of the rec. So the new program would be to generate the square wave on the port 1. So I hope it is done from your side. So I am going to reset the code OEN. Okay. Maybe Amar sir is following there. Okay, now this time it is done. Okay, so I am just writing the code to generate a square wave on the port 1. So it is important question also, and definitely we would be able to see here. So this org0h again, and the command to provide it is a move. So first of all, we have to initialize the stack pointer since we are using the subroutine program. So for this one, that we have to apply the command which is move sp. So the program code is to generate the sequence, the square wave on the port 1. To generate the code, generate a square wave on the port 1. So we have to write the assembly language code for generation of square wave on the port 1. So the move sp, that's comma, that's hash 7h. So here this is the command to initialize the stack pointer since we are using the subroutine program. So again, we need to apply the label for sending the value the 00H on a port 1 to generate the low level of square wave, because we have to starting with the low level part, that is the assigning to the zero value. So that is the one of the sequence variant, which is move, the move P1, and the value is assigned 00, value is assigned to 00H. After that, we have to assign the new sequence gradient, which is A call delay, that is wait for some time. This is the command to provide the significant delay, that is A call delay. Now you can see this A call delay, it means the wait for some time. And again, we have to apply the higher value, that is we have to send the FFH, it means in the hexadecimal we have to apply the maximum value on the port 1, that is the high level of the square wave. So first of all, as the square wave we are going to follow over here, so for the square wave we have the maximum peak value and the minimum value, it is 0 and 5. So we have, so this time the new command which is required to assign, there is a move P1 with the value, and it is being assigned with the hash 0FFH. So what does it mean? It means that we have to send the FFH value on the port 1, that is the high level of square wave. And again we need to provide the delay, which is the significant delay, and for this one we need to provide the command which is A call, that is the A call delay, DELAY, A call delay. And again we need to give that particular sequence in the sequential manner. So for this one we need to apply the command, that is SJMP back. What does it mean? It is a reportedly significance value, and the meaning is that they will repeat the sequence. So for this one we need to apply the command SJMP back, as we have already assigned this back level. So again I am giving the same sequence instructions in the order. So definitely we have this move P1. First of all we need to assign the lower value to P1. Again we need to apply some significant delay. Again we have to apply some highest value, again and again. So definitely by using of this sequence, this we have to see the square wave, and definitely this square wave sequence that would be toggled by the LEDs, and one time the LED will be blinking, and after some significant delay your LED will not be blinking. So the square wave can be estimated by the interfacing of the microcontroller this time. So we need to check whether with the toggling of the LED, so if your wave is having the highest value, that is the highest peak, so the LED will be blinking, and if the value is lower, it means it is a 0 volt. So definitely your LED will not be blinking. So again, this SJMP, that is a back, that is a delay. So new assigned, there is a delay. So already we have assigned the delay label and the value, that is a move R1 by 0FFH. So it is the counting the load. So first of all, whatever the count we have, it is that we need to load the count over here, and again B, J and Z R1, DJ and Z R1, comma, again, as we have already assigned the label, again. So what does it mean? It means we have to apply the decrement count and repeat the process until we need to follow the count sequences to be 0, because we have to start with the highest value of the count, okay, and then we are just going through just decrement of the sequence, that is the decrement count and the repeat the sequence, and it is just being considered until the count is 0, okay, and again we have to return to the 0, and we have to end the program. So right now I've done this code once in a while. We have to check whether we would not have any kind of the sequence error. So first of all, we have to click on the reset. Now it is okay. So it is just being reset all these things. Again, we need to apply this step. Okay, so there is no error. Okay, then we need to go for the run. And right now you see if it is visible, your LED is blinking. Okay, now we are just going to follow the sequence. It is now you can see the LED is blinking. Okay, so here we have the LED blinking, and definitely, so if the LED is blinking, it is representing it is highest volt to the lowest volt, and the square wave is just being formed, and it is in sequence manner. So just complete the code and ask to the faculty there if there is any doubt, any form, then I will be here following sequence. And right now you can see the value of the R1 is being changed continuously. Okay. So hope so you understood this particular code, but I'm just going to elaborate something about the output value. So as already I told you, this is the code, and this is the gradient of the instructions to generate the sequence, to generate the square wave. Okay, and definitely if the square wave is generating, it means it is either in terms of the, because it is the gradient of the step functions, unit step functions. So unit step functions will be considered as a maximum volt, that is the peak value, and will be minimum volt, that is zero value. Okay, so here by the LED interfacing, we can show if the LED is blinking, it means it is showing the maximum value, and if LED is not blinking, it is showing that it is a 0 volt. So right now, for the square wave generation, as of now you can see it is in synchronous manner. LED is blinking and LED is not blinking. Okay, and you may have, and one side, if you can see from the left side, if the LED is blinking, the LED 7, 6, 5, 4, 3, 2, 1. So we have the combination of the LEDs which are blinking, and definitely you can see whether it is over here or not. Okay, so hope so you understood this part, and definitely we have the value changing. You can see over here. Okay, and completely the value as the data is also representing, and the data memory interfacing is also represented the maximum value which would be assigned completely. So here what I'm doing, so suppose if you are just changing, here we have the system clock frequencies, and this time system clock can be optimized if you just going to update the frequency here. Suppose I'm just providing them 50,000 megahertz this time, it is just in between faster. If you're providing right now, you're just thinking it is just giving the value which is higher than, and it is having the lower delay in between there. So suppose if it is providing this 100, so right now it will take time. So here we have the frequency which is lower than, and definitely we have. If we just changing the frequency level over here, then definitely you have the LED blinking. You can see, and definitely the blinking is not blinking. If you can estimate, it is being provided the square wave. One important point is that if you just are touching or interfacing with the port with the CRO, then definitely we can see the square wave. So this time from this 8051, we can generate the square wave, and this is one kind of the interfacing application also. Also, it is understood from this side. Tell me or tell to the Amarjit sir if it then issue any doubt. So the next program is going to discuss over here, which is toggling the port 1 with the LED. So first of all, we need to toggle the port 1 by the LEDs. So once if it is done, then tell to the Amarjit sir. So I will be discussing the new code again. Yeah, is it done? Is there any doubt? Shall we have a new code, new program for toggling the port 1 by LEDs? Okay, so I am going to arrange the new port, and that is the toggle, the port 1 LEDs. Port 1 LEDs we need to toggle. So first of all, we need to pause the code over here and reset, and again I need to arrange the code. So for the toggle the port 1 LED, once we need to assign the value, and that means because if we are just going to interface the LED, it means for the seven segment display, if we're just taking the port 1, that is the P1. So we have this A, B, C, D, E, F, G, H. That is E, F, G only. So 7 segments. So for the 7 segments, we need to take the data for toggling one LED. Okay. So once we need to apply some toggle. So I am just taking not exact meaning toggle. So just it is toggle. I have taken the label of toggle, and this is move P1 by the value, that is hash 01. So this hash 01 is being assigned, and after that I will assign the new command, which is execution of the delay. So for execution of the delay, we need to give the command which is CALL call, and this is DELAY. This is called delay. So it means we need to execute the delay. Okay. So the new instruction is to provide the value of accumulator to the P1. So to move P1 value to the accumulator right now. So here this is the command, just move A to the P1. So it means we need to move P1 value to the accumulator, because we have to take the sequence and we have to functionalize over here. And again, we need to give this complementary. So this is complement the A value. So for the complementing the A value, which is CPL, and that is A, CPLA, and it is having the meaning that is a complement A value. So after getting the complement, we need to apply the new command, which is assigning the value that already complemented. So that complemented value is assigned to the P1. So first we have to take the value that is 01 to the P1. This P1 value assigned to the accumulator. Again, this accumulator value is being complemented, and this complemented value is assigned another one to the P1. So again, we need to give the command. This is MOV P1 to the A. So this is accumulator. Okay, again we need to provide the significant delay, that is a called delay. Okay. Then SJMP toggle. Then again we need to assign the new label, which is delay, as already being assigned in the previous instruction. Okay, the delay, so it is MOV R5 hash 10H. So what does it mean? We are giving load register R5 with 10. It means here the 10 value is with the R5 register. Okay. Then next I am assigning the new label, which is 2 TWO, and the label is having the value, the load register R6 by 200, because we are going to signify the delay. So here this is 2 MOV R6 by hash 200. So we are assigning the value 200 to the R6, and again I am just going to assign the new level. Level is not sensitive That is not particular that the word. You can assign your any level, but that would be in the sequence manner over here. So it is the move R7 by hash 200. So it means the R7 register is with the value 200, and again this is required to decrement this R7 till it is being 0. So for this one we need to apply the command. This is D, J and Z R7 with dollar. So suppose if it is going for decrement the value to the 0, so it is the rest. It is need to provide the value. This is dollar. So this is D, J and Z R7 by dollar. Okay. Again we need to apply the value of the decrement, the decrement of the R7 till 0 in case when we are going through the R6 and R7. Okay, so this time I am just going to assign the new command, which is D, J and Z R7. I think I am wrong. This R7 is assigned. This R6. Okay, right now because already the R7 is being assigned. So this is R6Y1 ONE as we have already assigned. So now this time this R6 is being 0 until your R7 is going to be 0. Again for the R5 it is in the serial manner because the LED will be blinking and it is toggling over here. So this is D, J and Z R5 comma PWO. It is in sequence. Right now you can see for the 1 and for the 2, and it is one after the another, and we have to keep, and this time it is to be returned, and now the code is over the end. So right now I have to check after getting the reset. We have to check is there any. Okay, there is no error. So first of all we have to run this LED and we have to check, and we have to provide some faster sequence so we should not have any delay. So right now you will have the LED will be blinking with the toggling of the H as we have already provided. This is 0, 1. Now you may have a look. Now LED is being toggled. You can see your last LED is being toggled and your complete sequence is being toggled. So you have a 7-segment display. For the port 1, it is A, B, C, D, E, F, G. So right now which is going to provide, this is 0, 1. So 0, 1 means your last LED is being 1, but after that it is recall again from the processing with the side of the accumulator, and it is being complemented again. So once it is being complemented, and again the 7 LEDs, sorry, 6 apart will be on, then 7th will be off, then first to 7th on, all 6 will be in off. So these all are in complement manner, and definitely this code is completing, that is toggle the port 1 with the LEDs, and definitely we can have the interfacing with 7-segment display, and it is tremendous code if you are just running with that. And following of this, you can go for the complementary with the 2 LEDs, 1 LED, 3 LEDs, whatever you want to follow the manner, the sequence, you can attach over here, put your values over here, and you can generate a sequence. Even you can see what is the output. So right now, what is it mean? Here the code. The code is attached over here. The code is being executed based on the data memory. Interfacing will be completed, and definitely by 7-segment display, you can have the total of the LEDs on the port 1. And this code is ended over here. This code is just completed over here. And you may ask the questions. Amaji sir is following you. So just check whether it is working or not. The code, is there anything required or is there any error that you can ask frequently? So hope so. The code that I already shared to you, these were interactive to you, and many codes I have. So I will provide to you as a study material or the material for the interfacing with 8051 programming. And definitely this tool is completely free of cost, and it is open for all, and it is very easily installable that you can go for the installation because we have some executed jar file, and definitely it is good for us. And important point is that we cannot only run the assembly simple assembly code by using this EDCM 51 software, that we can use any kind of the interfacing by using this kind of software, as it is having the dynamic interface. So it is considered as EDCM DI software. This is dynamic interface. So it's good for you, and lots of codes are there. So you may simulate here with your hand, go through the various possibilities. One important point is that a good thing, whatever you have any error during the code running, it means the execution of the program, then definitely it will be mentioning over here, and it is good and user friendly. It's good for you. So just expecting the queries and the doubts from your side if it is in there.
Okay, so I want to give the vote of thanks to our director sir, because he has encouraged us and given us the opportunity within this very short period to organize such workshop. After that, I want to thank our HOD sir, Dr. Sandeep Chanda, for his all type of support from the department side and this taking the permission and other technical solve problem. And after all the faculty members from our electrical department to solve this problem. Okay, so students, thanks all of you for joining this workshop. Have a nice day. Thank you.
So I think the query would be accepted from your side, and you may consult with the faculty. So this time I'm just summarize the session. So thank you so much. Thank you for all for being with us, and thank you for your eminent patience. Is there any doubt or the query? Then you can consult with Dr. Amarji sir. So he would be happy to you, and the concerned materials and the software will be attached and definitely will be provided to you. Thank you so much.